Hello friends, welcome to IFAS. This is Manoj and today we are going to discuss one of the important topic for CSIR-NET, GATE and IIT JAM examples. So the topic name is countable and uncountable sets. Okay, so in this lecture we will see the meaning of countable and uncountable sets, their properties and cardinal numbers, algebra of their cardinal numbers also. And after that we will solve some examples of countable and uncountable set which ask in CSIR-NET exam. Okay, so let us start with some first definition. The first definition is similar or equivalent set. So two sets, I will take two sets, set A and B, set A and set B. The two sets said to be equivalent set or similar set if there exists some bijective function between them. Okay, so I will take my two sets set A and set B. Okay, if I take my two sets set A and set B, and if I'm able to find some function f from A to B, if I'm able to find a function f from A to B such that the f will be our bijective function. Okay, so if I'm able to find some bijective function f from A to B, then two sets A and B will be similar set. Okay, so it is not necessary that all the function from set A to set B are bijective functions. So if I am finding some constant function on the from A to B, then it is not necessary that the function will be bijective function again always. Okay, it is actually a function but which is not bijective. But if I'm able to find at least one bijective function from set A to set B, then the two sets will be our similar sets. Okay, so the notation for similar set is this. Notation for similar set, now the note is two finite set are similar if and only if their cardinality are equal. Okay, so if two sets are finite, then they are similar if and only if their cardinality. The cardinality means what? The number of elements in that set. Okay, so number of elements in that sets are equal, then the set will be our similar set. So the next definition, that is finite set. This is a simple definition that if the cardinality of the set is finite, then the set will be a finite set. That means the number of elements in the given set is finite, then our set will be finite set. Now the next one is countable infinite set. This is actually important definition. What is countable infinite set? Okay, definition is a set A is said to be countably infinite if it is similar to the set of natural numbers. Okay, so of course it is a similar to set of natural numbers. So by definition of similar sets, there exists some bijective function again. By definition of similar set, there exists some bijective function f from set of natural number to set A. Okay, हमारा A अगर n से सिमिलर होता है तो वहां पे एक बाइजेक्टिव फंक्शन डिफाइन होना चाहिए सच दैट f from n to A is a bijective function. Okay, so अगर ऐसा फंक्शन एग्जिस्ट होता है तो n जो होगा वो A से सिमिलर हो जाएगा एंड A is also similar to n, and in that case we say that our A is countably infinite. Okay, so if I am able to find some bijective function from set A, from n to set A, okay, if I am able to find some bijective function, then I can write my set A as f of 1, f of 2, the image of 1 under f, that is my f of 1. This is the element of A. Okay, and here the f of 1, that means that this element I will take it as my A1 element. So it has exactly one preimage because the function f is a 1 1 function. Okay, so function 1 1 आता है, इसके वजह से वो जो preimage जो आएगी हमारी 1 की, f of 1 की, that is A1 की, वो exactly 1 आएगी, that is my 1. Again f of 2 की, that I will take as my A2. इसकी जो प्रीमेज आएगी that is again exactly one preimage. It has exactly one preimage. So I can count my elements. I can count the elements of this set. Right? So if I am able to count this element of this set, then the set will be our countable. Right? So this is our countably infinite set. The next definition is countable set. So the definition is a set A is said to be countable set if it is either countable or finite set. तो अगर वो सेट फाइनाइट होता है या फिर काउंटेबल इनफाइनाइट होता है तो वो जो सेट बनेगा वो काउंटेबल सेट बनेगा. सो द एग्जांपल्स इज ऑब्वियसली एवरी फाइनाइट सेट इज काउंटेबल सेट. द नेक्स्ट एग्जांपल इज set of natural numbers. So I can find a bijection map from set of natural numbers to set of natural number. That is my identity function. I will take f of n is equals to n. Okay, so ये मेरा identity function हो जाएगा और इसकी वजह से I can say that n is countable set. Similarly, I can find the bijective function n from n to set of integer, that is, we'll take f of n is equals to -1 to the power n into greatest integer function of n by, okay. तो ये जो फंक्शन होगा, अगर हम इसको चेक करेंगे तो ये भी क्या बन जाएगा, बाइजेक्टिव फंक्शन बन जाएगा, विच इज 1 1 एंड ऑन 2 फ्रॉम सेट ऑफ नेचुरल नंबर टू सेट ऑफ इंटीजर. So set of integers is also countable set. The next one is q. Q is also countable set. Now the next definition is uncountable set. What is uncountable set? A set which is not countable set. Set which is not countable set is called uncountable set. Okay, so जो भी set countable नहीं होंगे, that means वो countably infinite भी नहीं होंगे और finite भी नहीं होंगे. अगर ऐसा होता है तो वो जो set बनेगा वो uncountable set बनेगा. So examples are set of irrational number and set of real numbers. Okay, so now we will define the two cardinalities. The first one is set of natural number, that is our countable set. You can also set countably infinite set. Okay, so this is our countably infinite set, and the next one is set of real numbers, that is my uncountable set. Okay, I will take two notation for the two different cardinality. There are two types of set. The first one is countable set and the next one is uncountable set. Okay, so the set of natural number, this is countably infinite set. I'm not saying that set of natural number is finite set. Okay, this is countably infinite set. So the cardinality of countably infinite set is aleph naught. The next one, the cardinality of uncountable set is continuum. We know the cardinality of finite set. We have denoted the cardinality of countable infinite set, that is aleph naught, and the last one we have denoted the cardinality of uncountable set, that is continuum. Okay, so there is some algebra for cardinal numbers. These are two cardinal numbers, so there is some algebra. जैसे कि हमने algebra देखा है, sequence का algebra देखा है, series का algebra देखा है, लिमिट फंक्शन का लिमिट ऑफ ए पॉइंट उसका जो लिमिट है उसका अलजेब्रा देखा है, कंटिन्यूटी का देखा है, डिफरेंशिएशन का देखा है. सिमिलरली यहाँ पे भी कार्डिनल नंबर्स का कुछ अलजेब्रा है. द फर्स्ट वन इज n is strictly less than aleph naught, which is strictly less than c. This is true for any natural numbers. Next one is aleph naught plus c. Aleph naught plus c is equals to c. After that, aleph naught into c is again c. After that, the fourth one, n plus aleph naught is equals to aleph naught, and n into aleph naught is again equals to aleph naught, and this is true for any natural number. This is not true for n is equals to 0. Therefore, we have taken n is a set of natural numbers. Okay, so set of natural number does not contains element 0. Or the next one, the n times multiplication of continuum is again continuum. Right. The next property, the next algebra is n times summation of aleph naught is again aleph naught, and the last one and the most important is aleph naught to the power aleph naught is equals to 2 to the power aleph naught, which is again equals to aleph naught to the power c, and which is equals to c. Okay, c is continuum actually. So most important, because हमारे जो कार्डिनल सेट, हमें जो सेट डिफाइन किया जाता है जो काउंटेबल या अनकाउंटेबल है या नहीं ये चेक करना होता है, तो बहुत सारे सेट इसी प्रॉपर्टी से सॉल्व हो जाते हैं. यू विल सी दैट. Or the next properties of set, and this is related to the countability and uncountable. Okay, so ये जो properties है related है countable and uncountable से related properties है. The first one is countable union of countable set is countable. So if I take my set Sn, and this is for all n belongs to set of natural number, Sn is countable. Okay, so if I have taken the set Sn, and this Sn is true for all set of natural numbers, and if I am taking its union, okay, so if I am taking its union where each Sn is countable, then this countable union of countable set will be countable. This implies that our S will be countable. Okay, that means the countable union of countable set is countable. Now the next one, the family of all finite set of countable set is countable. Okay, the family of all countable set, I will take my set of natural number and its family, that means I will take its power set. Okay, इसका power set में कौन से एलिमेंट आएंगे? That is the of all subset, that is all subset of natural numbers. Okay, subsets are singleton 1, singleton 2, and so on. Also 1, 2, set of all sets of cardinality 2. After that, These are also subsets of set of natural numbers. Okay, Twicean, Thricean. That is what is Twicean? Twicean is the elements of the form 2 into n, that where n belongs to set of natural. Okay. So the second property is the family of all finite set of countable set. This is my countable set, and the family of all finite set. This is finite. Okay, so these are finite sets, but this is not a finite set. This is not a finite. So जो फाइनाइट सेट होंगे, काउंटेबल सेट के जो फाइनाइट सारे के सारे सेट होंगे, तो उनके जो हम यूनियन लेंगे, उनका जो सेट बनाएंगे, नॉट इट इज उनका जो सेट बनाएंगे, वो जो सेट आएगा वो काउंटेबल. Right. The last one, the next one, the family of all infinite set of countably infinite set. If I am taking this is as my countable set, if I am replace countably infinite is countable set, then countable set also contains finite set. Okay, and there does not exist any infinite set which is a subset of finite set. Okay, so set is finite if and only if it has a countably infinite subset. This is actually one of the property of infinite set. कि अगर वो infinite कब होगा, जब उसका कोई countably infinite subset होगा. तो यहाँ पे मैं countable set नहीं ले सकता, हमें यहाँ पे countably infinite set लेना होगा. So family of all infinite set of countably infinite set is uncountable. So this set will be uncountable set. So if I take on the family Twicean, Thricean, okay, so I will take the family of this, that is my Twicean, Thricean and all others also. ये जो होगा, ये जो सेट आएगा वो अनकाउंटेबल सेट आता है. दिस सेट इज अनकाउंटेबल सेट. So the next property is finite Cartesian product of Z of countable set is countable. Okay, so if I take Cartesian product of countable set, my finite Cartesian n times, ये जो सेट आएगा ये काउंटेबल होगा. क्यों? क्योंकि सारे के सारे n काउंटेबल है. If I take Z cross Z n times, then again it is countable set. But if I am taking at least one of them is uncountable, so if I replace this my n by r, okay, if I am replacing this n by r, then this set will be a uncountable set, because इसकी कार्डिनलिटी क्या आ जाएगी, कि जो कार्डिनलिटी आएगी वो कार्डिनलिटी ऑफ a क्रॉस b, ये क्या आ जाता है, दैट इज इक्वल्स टू कार्डिनलिटी ऑफ a इंटू कार्डिनलिटी ऑफ b, राइट. So multiplication, the cardinality of cross product is their multiplication, cardinality of both sets. तो यहाँ पे जो कार्डिनलिटी आएगी वहाँ पे c मल्टीपल जाएगा अलेफ नॉट को, and अलेफ नॉट into c becomes c. That means the cardinality of that set will be c, and therefore the given set will be uncountable set. But अगर मैं सारे के सारे countable set लेता हूँ, तो in that case the finite Cartesian, the Cartesian product will be finite. Okay, so finite Cartesian product of countable set is countable. The fifth one is infinite Cartesian product of countable set is uncountable. If I am taking this multiplication is infinite times, then the set will be uncountable. ये जो set बनेगा हमारा नया, वो set क्या बन जाएगा, uncountable set बन जाएगा. Now the next one, arbitrary collection of disjoint open interval is again countable set. Arbitrary collection of disjoint open interval. I cannot say that, I am not saying that 0 1 union 2 1 2 3. Okay, so this disjoint open intervals. I'm not saying that this set is countable set. I'm saying that the union, उसका जो union होगा, that means this is my one element of set. This is my second element of set. Okay, this is not actually set. This is not actually set. I am taking it as my one element of a set. Okay, तो अगर disjoint union लेते हैं, arbitrary disjoint union लेते हैं, तो वो भी क्या बन जाता है, countable set बन जाता है. Now the counting number of functions. Okay, so number of functions कितने रहते हैं? If I am taking the function f from a to b, if I am taking the function of f from a to b, then the cardinality of set a is alpha, cardinality of set b is beta. Then set of all functions f which is of the form f from a to b has cardinality b to the power alpha. Okay, तो कोडोमेन की जो cardinality होगी वो cardinality to the power cardinality of domain. That means cardinality of b to the power cardinality of, okay, these are total number of functions. Now the note is, let f from a to b be a function f from a to b be a function, then the first one is if f is 1 1, if f is 1 1, then cardinality of a less than cardinality of, right? If I am taking, this is my set a, this is my set b, तो अगर मैं यहाँ पे 1 1 अगर मैप डिफाइन करता हूँ, तो 1 1 डिफाइन करने के लिए क्या होगा, यहाँ पे एक एलिमेंट इधर जाता है, एक एलिमेंट दूसरे एलिमेंट को जाना होगा, क्योंकि वो 1 1 है, वो एलिमेंट पहले एलिमेंट को नहीं जा सकता। तो जितने एलिमेंट सेट ए में है उतने सारे के सारे जो एलिमेंट्स होंगे वो किसी डिफरेंट एलिमेंट्स को मैप करेंगे बी के सेट में। तो बी में एटलीस्ट उतने एलिमेंट चाहिए जितने एलिमेंट सेट ए में है, बी में एटलीस्ट उतने एलिमेंट चाहिए जितने सेट ए में है। और अगर ऐसा होता है तो बी की कार्डिनलिटी एटलीस्ट, कार्डिनलिटी ऑफ बी इज एटलीस्ट बी, एटलीस्ट कार्डिनलिटी ऑफ बी इज एटलीस्ट ए और इट इज ग्रेटर देन ए। सो इट मे बी ए or greater than a. Cardinality of B may be cardinality of A or it is greater than. Okay, so this is when the function is 1 1. The next case is f is onto, then cardinality of A is greater equal cardinality of B. The same we can say that अगर यहाँ पे एलिमेंट्स अगर रहते तो उनकी प्री में जो आएगी, उनकी प्री में जो आएगी वो है तो दो एलिमेंट्स को जाएगी या फिर एक एलिमेंट को जाएगी। अगर वो एक एलिमेंट को जाती है प्री में, वहाँ पे 1 1 मैपिंग हो जाएगी, और 1 1 मैपिंग अगर होती है तो इन दैट केस वो जो बनेगा ऑन टू फंक्शन है, या इट इज ऑन टू फंक्शन। अगर वो ऑन टू बनता है तो क्या बन जाएगा, रेंज सेट जो बनेगा वो हमारा टोटल कोडोमेन बनेगा। तो अगर रेंज सेट टोटल कोडोमेन बनता है तो कोडोमेन के सारे एलिमेंट्स को प्री इमेज रहेगी। तो अगर प्री इमेज अगर रहती है तो कोई भी एलिमेंट्स अगर लेंगे तो उसकी प्री इमेज एटलीस्ट एक तो होगी। दैट मीन्स कि जितने एलिमेंट सेट बी में है उनकी एटलीस्ट एक प्री इमेज यहाँ पे हमें मिलनी चाहिए। एंड वो एक प्री इमेज अगर मिलती है तो दूसरा कोई एलिमेंट्स, ये अगर इसको मैप होता है, दूसरा कोई एलिमेंट्स इसको मैप नहीं हो सकता, क्योंकि अगर ये मैप हो जाएगा तो वो फंक्शन ही नहीं रहेगा, राइट। तो दूसरा जो एलिमेंट होगा वो दूसरा किसी और एलिमेंट्स को मैप होगा। दैट मीन्स बी की कार्डिनलिटी जितनी होगी उतनी कार्डिनलिटी एटलीस्ट एक ही होनी चाहिए, और ए की कार्डिनलिटी उससे ज़्यादा भी। ओके, सो दिस आर ट्रू प्रॉपर्टीज ऑफ फंक्शन लेट एफ फ्रॉम function from A to. Okay, so now we will see the example, the first example. Which of the following set is countable? You have to check which of the following set is countable. The first option is the set of all function from Q to Q. That is the first one is, that is my capital F. Okay, I will take, this is my capital F, that is all functions such that F is from Q to Q. Okay, तो ये जो मेरा फंक्शन है यहाँ पे क्या है, here cardinality of Q is what? This is countable set, and it is countably infinite. So cardinality of Q is Aleph naught. Okay, so this implies that cardinality of F is equals to Aleph naught to the power Aleph naught. That is cardinality of Q to the power cardinality of Q. And what is Aleph naught to the power Aleph naught? That is Aleph naught to the power Aleph naught, and that is equals to C, right? तो इसकी जो कार्डिनलिटी आएगी वो C आएगी, which is कार्डिनलिटी of R, and R is uncountable. So set of all functions from Q to Q has कार्डिनलिटी C, and therefore this set will be our uncountable set. Okay, so ये जो set आएगा वो uncountable हो जाएगा. So the next one, the set of all functions from Q to 0 1. Okay, so the next one is, I will take all functions such that F from Q to single, the two element set, that is 0 to 1. Okay, so here cardinality of Q is again Aleph naught, cardinality of 1 2 is what, cardinality of 1 2 जो होगी that is 2. Okay, the total number of elements of cardinality of F is equals to 2 to the power Aleph naught, and that is again equals to. Okay, वो जो सेकंड जो सेट होगा वो भी क्या बन जाएगा, अनकाउंटेबल, बट वी वांट द काउंटेबल सेट. The third one, the set of all functions from Q to 0 1 which vanishes outside of finite set. तो finite set के बाहर जाने के बाद वो जो सेट बनेगा, finite set के बाहर जाने के बाद जो भी सारे के सारे infinitely many एलिमेंट जो रहेंगे वो किसको मैप होंगे, that maps to 0, and this is true for all sets which are finite. तो फाइनाइट सेट, अगर कोई भी फाइनाइट सेट लेते हैं के बाहर जो भी एलिमेंट जाएगा वो क्या जाएगा, 0 को मैप होगा. तो इन दैट केस वो जो मैपिंग जो होगी वो फाइनाइट सेट की मैपिंग होगी. फाइनाइट सेट टू 0 1 की मैपिंग होगी, राइट। वो जो मैपिंग होगी तो वो फाइनाइट सेट की मैपिंग, फाइनाइट सेट टू 0 1 की मैपिंग होगी। Okay. So set of all functions such that f from q to close 0 1 comma f of x is equals to 0. This is true for all complement of finite set. Complement of finite set. तो ये जो मैपिंग होगी वो फाइनाइट सेट के बाहर जाएगी, दैट इज 2 to the power सम फाइनाइट सेट। वो जो कार्डिनलिटी जो होगी, कार्डिनलिटी ऑफ f3 जो होगी वो क्या बन जाएगी, 2 to the power सम फाइनाइट सेट बन जाएगा, एंड देयरफॉर वो क्या बन जाएगा, एक फाइनाइट नंबर बन जाएगा, एंड देयरफॉर दिस सेट विल बी अ काउंटेबल सेट। एंड द लास्ट वन, द सेट ऑफ ऑल सबसेट्स ऑफ n, जैसे कि हमने प्रॉपर्टी में देखा था कि अगर मैं फाइनाइट काउंटेबल अगर लेता हूँ, फाइनाइट सेट अगर लेता हूँ, सारे इनफाइनाइट सेट अगर लेता हूँ काउंटेबल इनफाइनाइट सेट के, तो उनका जो सेट बनेगा वो अनकाउंटेबल सेट बन जाता है। सो देयरफॉर दिस ऑप्शन इज नॉट करेक्ट ऑप्शन। Okay. The next one is, let S be an infinite set. Which of the following statements are true? Okay. तो yes अगर infinite set बनता है तो in that case I will take the function f from s to n. Okay. So in that case, if there is a injection from s to n, injection means what? There is a 1 1. Okay. So 1 1 अगर होता है तो if f is 1 1, if is a function from s to n such that f is 1 1, in that case cardinality of s is less equal cardinality of n, but the cardinality of n is countable, this is a countable set n, तो s की जो cardinality होगी वो लेस देन n आएगी, दैट मीन्स s का जो होगा वो क्या बन जाएगा, काउंटेबल बन जाएगा। अगर ऐसा हम सर्जेक्शन अगर लेते हैं तो सर्जेक्शन अगर होगा f is on 2, तो cardinality of s is greater equal n, I can take the uncountable set also, here I can take n is uncountable set, and this is incorrect option। तो नेक्स्ट, इफ देर इज अ इंजेक्शन फ्रॉम n to s, ओके, तो इंजेक्शन फ्रॉम n to s अगर आता है तो इंजेक्शन फ्रॉम n to s आएगा तो वो क्या बन जाएगा, कार्डिनलिटी ऑफ n इज लेस इक्वल कार्डिनलिटी ऑफ s, ओके। In that case I can also take uncountable, so again this is not true, and the last one is cardinality of s is less equal cardinality of n, and this one last one is again true, okay। The correct options are option 1 and option 4। The next one, which of the following set is uncountable? The first one I can directly say that this is a cardinality of 2, cardinality of 0 1, the cardinality of r is 2 to the power c against c, and the first one is uncountable set. Again 2 to the power aleph naught is again c, that is again uncountable set. Now set of all finite subset of n, and this is a countable set, actually we have seen this property that finite set अगर हम लेते हैं तो वो जो set बनेगा वो countable बन जाता है। The set of all subsets of n, this is again uncountable set, we have seen that this is a uncountable, okay। So thank you so much